Hello, welcome back. I watched a video on YouTube made by Peter Lindemann. I studied his work. I studied more of his readings and all this. And he came up with a demonstration of this circuit with a motor that is attracted with a modified iron motor, so it's attracting iron. Here, this coil indicator is now my version of the replica of the Newman motor, and see if it does the same. So here we have a transistor. I'm using a 55 transistor. My input is 24 volts, and this way you can charge up another battery. So not the same battery, but another battery. And this is how it looks when you when you make soldering. So we have one transistor of 220 ohms. Between what was it? The base and the illuminator, and then a neon bulb between the collector and the illuminator, and then another 220 between the switch and the base. In Peter Lindemann's video, he used a reed switch. I'm still using my old method from using the switch, using the shaft as a switch. And yeah, currently I'm charging a battery. Well, I'm using 150 milliamps. I have a mechanical out, and I'm charging the battery here. It's a slow process, but he's recycling. He's using the motor. We have motor power, and we are charging a battery. So it's kind of Bedini way, because yeah, in Lindemann's video he's also discussing the circuit of John Manini. In this way you are not closing the loop, and I still don't believe in closing loop circuits. I really believe in open loop systems. Because when the input battery of the motor is getting empty, I have a fresh battery that I just charged with the motor and having mechanical output. So yeah, I just want to share this. So I don't have a commutator that puts directly voltage. I use it now really as a switch. And the transistor is really switching the load. When I disconnect the battery, you will see that the neon will flash. You really need this one, because if you don't, your transistor will be killed by this energy. So when I connect the battery, the voltage will yeah, start charging the battery. So in this setup I make a perfect combination between the Newman motor and the Peter Lindemann circuit. Yeah, I think this will be very beneficial for people that wants to try this and already built one Newman motor. This circuit is a perfect way for this study. So I am using one battery to power the motor and switched by a transistor that I'm translating back to the battery, and the battery is charging. So in half hour I probably have a fresh battery. So when the input is empty I can just swap it. So for anyone who wants to try, again, this setup here is done by this. One side of a coil goes on the collector. Between the collector and the eliminator is the neon bulb to protect it when there is no load. Between the base and the eliminator I have a 220 ohm resistor, and then between the base and the switch, this one goes to the commutator switch, is another 220 ohm resistor, and then we have the minus going on to the eliminator and the plus directly on the frame that is between the switch and the other coil input. Then to make the charge action you have to put on the collector output, where the other side of the coil is, you put a diode, and that diode goes to the plus and the minus to the other side of the coil, and in this way you can charge your battery. So, and the circuit is using only 150, 140 milliamps, charging the battery, second battery, with this method designed by Peter Lindemann.